Okay, I'm Professor Ho-Bun from the Department of Physics in HKUST. So today I'm going to give you an introduction to our undergraduate physics program. So in our physics program, we do not only train physicists. We try to educate students with analytical skills so that they can participate in works in all sectors of the society. So there are a lot of universities in Hong Kong have a physics department. So what is special about the physics department in HKUST? So first of all, we have eminent faculties and with reputation. So we have 36 professors, and the PhD degrees are obtained from world-renowned universities, okay, including Princeton, MIT, Cornell, Oxford, etc. And out of these 36 professors, 11 of them are American Physical Society Fellows, and one of them is a Nobel laureate. For American Society Fellow, you may or may not know what it is about. So a fellow, so most physics researchers are members of this American Physical Society. And every year, about 0.5% of them are nominated and elected to become a fellow. And you can see that out of the 36 professors that are in our department, 11 of them are American Physical Society Fellows. So we have our research is world-class, and also we are very committed to the quality education of our undergraduate students. So I'm going to describe to you some of the research in our department first. So this is the result of the research assessment exercise by the University Grounds Council. So the UGC is the government agency that distribute research funds to the universities. And every few years, they will undertake an assessment of the research in the universities. And this is the result of the latest research in 2014. You can see that they rank all the universities in physics and astronomy. And they use a star system very similar to DSE. So 4-star means world-leading research, and 3 stars means international renowned research, and so on. And you can look at the column for the row for HKUST, and you can see that about 39% of our research is ranked as 4-star. And this is all public available data. And you can go and into the UGC website and look for this data by yourself. And another very common, well-known ranking is the Qos ranking. And I think you are very familiar that Qos ranks universities. And in addition to universities, they also rank subjects according to the department. So this is the ranking of the physics and astronomy department all over the world. So I list only the ones in Hong Kong, and you can see that in Hong Kong, only 2 universities is within the top 100 in ranking, and HKUST is one of these universities. So the research in HKUST physics department, we already have established strength in theoretical and experimental condensed matter physics, and also in nanoscience and technology. So let me give you some examples. So this is some awards that is won by our faculties. This is Professor Shang, Professor Chen, and Professor Jason Yang. In 2013, they won the Berlin Medal by the International Phononic Society. I think you all have heard about photons, right? Photons is related to light. Here is not photon, here's phonon with an N. So phonons are related to vibrations in a solid. And the research of these 3 professors is that they make use of some metamaterial that can absorb low frequency sound very effectively. So if you are ever disturbed by noise from your neighbor, you notice that it's usually the low frequency noise that gets through. A high frequency noise is relatively easy to block out or absorbed. But to absorb low frequency noise, you need very thick material usually. And the research of Professor Chang, and Professor Yang on metamaterial make it possible to use very thin metamaterial and still absorb a low frequency sound very efficiently. And this is another example. This is Professor C.T. Chan's award. He got an Area of Excellence award in research together with another group. So these two groups get up to $100 million funding from UGC for a team of researchers. So the picture that you see on the background on the left-hand side is actually a material with a refractive index equal to 0. So I think you all know that refractive index, the concept of refractive index, right? The refractive index of air, for example, is equal to 1. And the optical fibers, for example, is based on the total internal reflection, right? Total internal reflection can only occur when light goes from a high refractive index medium into a low refractive index medium. So here we have a material for a certain specific range of frequency. The refractive index is 0, but even smaller than air. So you can imagine that there are a lot of possible applications for this kind of material with very unusual optical properties. A few more examples on the kind of condensed matter research in HKUST. In the top left-hand corner, you see the word HKUST, and each circle is actually an atom. So in Professor Ninan's group, he used a scanning tunneling microscope that can manipulate these atoms and put them at the specific locations and image them also using the same microscope. On the top right-hand corner, this is the research by Professor Wang Ning's group. He made very thin carbon nanotubes that can show superconducting properties. So this is a very important discovery in our department. On the top, in the lower left-hand corner, this is the acoustic metamaterial that I talked about earlier that can absorb low-frequency sound very effectively. In the lower right-hand corner is a picture of actually my lab. There's a dilution refrigerator in my lab that can cool solid samples down to 0.05 Kelvin. Right, so I think you have all heard about the Kelvin, the absolute temperature scale. 0 Kelvin, right, is minus 273 Celsius. It is when all the gas molecules stop moving. So using this machine, we can achieve a temperature of only 50.05 Kelvin above absolute zero. So it allows us to study a lot of phenomena that only occur at these low temperatures. Okay, so what we have talked about so far is mostly nanoscience and technology and condensed matter physics. What you may not have heard about is that recently our department have expanded into particle theory and cosmology. So particle theory is also known as high energy physics, and cosmology deal with the universe, the beginning of the universe, the evolution, and also the fate of the universe. So we already have a few faculties that have joined us, including cosmologists, and high energy theorists, and string theorists. And that means that we can offer more courses in this area, and also students will have the opportunity to participate in research that are supervised by these professors. Our goal is to become the center of particle theory and cosmology research in this region. So if you are interested in this field, I encourage you to look into our program in more detail. Okay, so I have talked a lot about the research in our department. So let's describe the undergraduate curriculum. So we know that students have different career aspirations, and the physics curriculum is designed to be very flexible so that we can cater to students with different aspirations. If you are a student who plan to do further studies, meaning that after graduation from your undergraduate degree, you want to pursue a PhD study, then our curriculum can give you very rigorous academic training and research experience so that you have a very strong foundation for your further study. And for other students who may not want to go into research, they will learn analytical skills and problem-solving techniques so that they can contribute to all sectors in the society. This is a diagram of our undergraduate program. Each block here represents a series of courses that students must take to satisfy the requirement. So the top block is the basic requirement of the BSc in physics. It consists of a series of courses. For example, classical mechanics, electromagnetism, quantum mechanics, thermodynamics, and some lab courses. So to graduate from HKUST, all students need at least 120 credits. So each course is approximately 3 credits. If you look at the what is required in the top rectangle, the BSc in physics, you'll find that that accounts for about 100 credits. So what happened to the remaining 20 credits that you need to graduate? So for these 20 credits, students can actually choose anything they want, any courses they want. And in a lot of cases, they will choose to also declare a minor in another subject. So a lot of our students in physics will do that. Actually, over half of the students will choose a minor in another subject, and they believe that this will further their knowledge and also may be helpful in their future job in the career. And they choose subjects. They choose minors such as mathematics, computer science, business, humanities, or even sustainable energy research. This is a lot of our students take part in minor as well. But there are also other students who want to do more physics, right? They think that 100 credits of physics is not enough. So these students will use the remaining credits to take more physics courses. And then we have 2 options and 1 track that they can guide their study. So for example, the International Research Enrichment track and also the honors physics option are both for students who are interested in having a research career. So after they finish their undergraduate, they want to continue study in PhD programs. In particular, the International Research Enrichment track will guarantee a student that during the 4 year in HKUST, they will have a chance to go abroad to participate in research in a foreign university. The physics and mathematics option is another option. It is mainly for students who want to do theoretical physics research. So in doing theoretical physics research, a lot of the time mathematics skills are also are required. So for those theorists, they need to take more mathematics courses, and we have the mathematics, physics and mathematics options for them. And also as an example, for example, in quantum mechanics, right, there are actually 2 courses in quantum mechanics. And the one that you see that is required for all physics students, quantum mechanics 1, all physics students will need to take it. But for quantum mechanics 2, it is a required course for the honors physics option and International Research Enrichment track. It is required for these students because they need a even more knowledge in quantum mechanics so that they can continue, right, to have a better preparation for their research career. Apart from required courses, there are also elective courses. So elective courses are courses that students are not required to take. They only take these courses if they are interested in these topics. So for example, we have courses on optics, material science, machine learning, and atmospheric physics. I also want to mention a minor in astrophysics and cosmology. So you might remember that I said earlier that we have a new team of particle theory and cosmology. And with the new professors, we can have experts, right, that are teaching courses in this area. So the courses include astrophysics and astronomy, introduction to stellar astrophysics, particle physics and the universe, and also Big Bang cosmology and Big Bang cosmology, right? So if you are interested in this field, right? So this minor is a minor that has been established in the last few years, and it give you opportunity in learning these topics from the world-leading experts. Okay, a lot of our students are also very interested in international exchange. So the exchange program usually refers to a student spending one summer, a summer or a regular term in a foreign university. So our School of Science has exchange arrangements with a lot of top universities in the world, including Columbia University, Kyoto University, University of California, and so on. In particular, the Department of Physics has an arrangement with CERN. It is the lab in Europe for doing doing high energy physics. And every year we have 1 or 2 students who go to CERN for summer exchange. Right? CERN is the place where the Higgs boson, right, the God particle, right, was discovered. And every year we send some of our students to do summer research in this laboratory. So if you, for students who graduate with a undergraduate degree within our department, they are competitive with all the other, with the top students in the top universities. So this slide lists some of the universities that our students has been accepted into. And you can see that these are all top universities in the world. And let me give a specific example of 1 year of our alumni, 2005. So this is a picture of our alumni from that year. And on the right-hand side, you can see that the text is after their UG study. They go to the graduate school. This is the red is the place they go to graduate school, and the purple is the place that they are working currently, that they are working right now. So for example, you can see that some of them went to, for example, Columbia and become a professor in UC Riverside, or some of them they work for now the Hong Kong Observatory. In particular, I want to describe person number 4 here, Professor Vic Law. He is actually a graduate of our department back in 2005. He went to Brown for his PhD, and now he has, a few years ago, he has come back to HKUST to become a professor in our department. And we have this picture, we have this photograph mainly because of his connections to his classmates. Right? He still keep in touch with his classmates, and he know the whereabouts of his classmates. And you can see that our graduates can do very well after graduation, and they can get top positions in very good universities. So part of our, some of our students will continue their study, but the remaining will contribute, right, to other sectors in the society. So to help students for getting jobs after they graduate, we have summer internship opportunities in our department. So in particular, we have students who go to some technology startups to gain working experience. For example, in the past summer, our students have worked in the Light Innovation Technology Limited and also the Acoustic Metamaterials Group. Right? These are 2 technology companies based in Hong Kong. And I think they they are very happy that the performance of our students, and they've indicated they will be interested in continuing to take our students in the future. Another career path for students in physics is teaching, right? Teaching in secondary school, for example. So to get a job as a secondary school teacher, it is essential to have some teaching experience. So we have an arrangement with secondary schools for our students to go there in the summer and participate in teaching secondary school students. And the photograph you see at the bottom is that the two students bring the high school students back for a tour of our university in the summer, right? And I think if you are interested in becoming a secondary school teacher, this kind of opportunity will be very valuable to you. Okay, so last, let me just present to you the career path of the students who graduated in the previous year. So in most, in our previous experience, about 1/3 of our students will participate in research. About 1/3 to 1/2 of our students will continue their study. So you can see here the largest largest fraction of students is for further studies. So last year we have more students going into further studies than normal. And as I mentioned, education is also a very major, another major route for our students, and it includes high school students, for example. And also, apart from that, there's government and commerce and business and so on. Okay, so I think this is all I want to all the information I want to give about our department. And if you want to get more information about the undergraduate program for the physics department in HKUST, you can go to the website at the bottom of this page. And for JUPAS application, two of the choices will be relevant for physics. If you plan to become physics students in HKUST, you need to choose one of these two JUPAS choices. The first one is the IRE, JS 5101, and the other one is Science A, JS 5102. This is a little bit different from previous years, that the science school admission has been divided into A and B. So only students in Science A option will be directed, will declare major in the physics department. So if you are interested in becoming physics students, make sure you choose the correct JUPAS choice. Okay, so I hope this video is useful to you for getting some knowledge of our department. If you want more information, as I said, please go to the website listed at the bottom of the slide. Okay, thank you for your attention.